is fine, but this is Ethernet.
You ready?
I'm ready to go. Yeah. And Paul is ill. Paul is ill, I think. But note taking will take care of it.
Okay, and the 2 minutes is up. This is the DNSOP working group at IETF 122. Next, please. So welcome to DNSOP. Your chairs are here. Well, Tim is here remotely. Benno and I are here in real life. We have a new area director. I don't see if he's here.
Yes.
Aha. Med, did you have a couple more words you wanted to say?
Yeah, so first of all, many thanks to, I would say, to Warren for the work done in the, I would say, for DNSOP, and I would say trying to have the working group carry on the work here. And I'm very pleased to work with you all here in the DNSOP. I am not an expert on DNS, but we'll be working together.
Thank you. So different personnel, but DNSOP. Thanks, Paul Hoffman, for taking the minutes. Next. Next. Yeah, there we go. The note well, you have seen it, but read it again. You're expected to understand it, and we kind of have to hold people to it. And if you haven't read it in detail, take a couple minutes. Next. Also, the IETF Code of Conduct guidelines in RFC 7154. Please, 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 continue to, we've actually had very good environment, people have told us in recent times. Let's keep that up. We take it, and just as the chairs, we have to say we do take the Code of Conduct very seriously. If anybody feels the code has been violated, please reach out to the chairs or the IETF Ombuds team. We work as individuals, so let's remember to be nice to each other. Next. Also, IETF meeting tips, if you're here in real life, it's great to have you here. Make sure you sign into the session using MeetEcho on site from the data tracker agenda. Use MeetEcho to join the mic queue. Having only one mic queue is a lot easier for us. Keep audio and video off if not using the on-site version. And for remote participants, we're happy to have you too. Make sure your audio and video are off unless you're chairing or presenting during a session, and use of a headset is strongly recommended. Next. So our agenda today, as usual, the agenda bashing moments, drafts for consideration that people have brought to the group for comments, reviews, and so on. If we have time at the end of those scheduled drafts, we have a couple of others that people are willing to talk about. Next. So let's see, the first part of the agenda, we're going to have to switch things up a little bit. Schumann has asked, in the interest of his health, to go first. So he'll be talking about the key tag draft first, and then we have three drafts that fit together and that Johan Stensheim is going to discuss further. We then have DNS update with JSON, domain name system public key-based request and transaction authentication, which is 6.0 with the longer name. We will already have done Schumann's draft, but dry run DNSSEC and a top-level domain for private use are the last scheduled drafts for today. If we get to them, and we always include these in the agenda because even if we don't have time for them, people are asking for, authors are asking for review and comments on them. So you have right here, go ahead and read these drafts. If you're interested, contribute to the discussion. Next. And we try to keep the data tracker and GitHub up to date as far as what we're working on, or you can always just ask the chairs. And with that, I think we can get started with Schumann.
All right, thanks, folks. So just to be clear, there are no major problems with my health. It's just since Monday, I caught a little bit of a cold, and I wanted to apologize if I cough a little bit or my voice struggles, so I wanted to get it over with first. Today I'm going to talk about a relatively new individual draft on collision-free key tags for DNSSEC. Next slide, please. It's not entirely new. So Mark Andrews and I originally wrote this up during the week of IETF 120 in Vancouver last summer. And at that time, it generated some brief but positive discussion on the mailing list. The surrounding topic was kind of in the air at the time because Keytrap was being discussed, and it was even presented, I think, at the ANRW workshop that happened at the same IETF. And we originally even had one of the Keytrap researchers, Elias, on the draft with us. For various reasons I won't go into, he had to bail. I eventually tracked down and recruited Yorgos from NLNet Labs to help us flesh it out. So we put out the -01 recently, which is essentially the same as 00, just unexpired. Next slide, please. Just the abstract. I'm not going to read it here. You can do that yourselves. I'm also not going to explain what a key tag is or what it's used for. I assume everyone in this audience knows, but in the abstract and in the body of the document, there is background and explanatory text about that. Next slide, please. I'll take over this. Wait, hang on. Where did it go? All right. Oh, it's a little slow. Okay. I'll just let you do it. I won't interfere. Would you advance to the next slide, please, Benno? All right, great. Okay, so we'll just jump into the meat of the proposal, which is that what we are proposing to do is to formally update the DNSSEC protocol specifications to entirely disallow colliding key tags for the same algorithms in the same zone. So in the DNS key RR set for that zone. There are a few ways we could do this. We could enforce the new key tag collision-free semantics on all newly defined DNSSEC algorithms going forward. If we wanted to apply those semantics to pre-existing algorithms, we could define aliases for them, so new algorithm numbers. And if you use those algorithm numbers, then the new ones, it's the same algorithm, except with the added constraint that it would have these collision-free semantics. And this is not a new idea. We've done this before, as we know, with the introduction of NSEC3. I think that was algorithm 6 or 7, something like that. So we know how to do this. Of course, it would also require a transition period and an algorithm rollover, but we all know how to do those things too. Right? So the other possibility is that we could uh, uh, agree to impose the collision-free semantics on existing algorithms at some future flag date. And we'd have to decide how far in the future that flag date would be and try to get the whole community on board. And this is also something that the DNS community have done. We've done a couple of flag days. I think there's probably some disagreement about how effective they are, but it is a possibility we can consider. Next slide, please. All right, so one of the primary motivations is to address computational denial of service attacks like the key trap vulnerability that employed specially crafted zones with many intentionally colliding key tags. You may be wondering, well, who cares anymore? That was in the past. We took care of it. All resolvers have effective mitigations now in the form of placing upper bounds on key tag collisions or other parameters that sensibly bound the work of the resolver, right? So that is all true. I agree with that. However, our position is there is another very important reason we should do this, which is to make DNSSEC validation as efficient as possible. So in our view, resolvers should never be forced to do unnecessary work to authenticate a DNS signature with an entire set of candidate DNS keys if they just happen to have the same key tag, right? So if we get rid of, if we restrict them to, if we restrict the protocol to not allowing any collisions, then the validator knows precisely which DNS key produced that signature and it has to do far less work. Let's see, next slide. All right, so how would you go about doing this in practice? Well, essentially, we'd have to make some small changes to the key generation process. And it turns out some implementations like ISC bind already do this kind of thing. And for the predominant case of single signers, this is fairly straightforward, right? So every time you generate a new key, you compute its key tag, and you compare it to existing key tags in the DNS key RSS to make sure there's no collision. If there is, you just throw it in the gutter, generate a new candidate key, go to step one, right? Next slide, please. A slightly more complicated case, of course, is with multi-signer configurations. Here, multiple distinct parties could be generating keys for the same zone independently. So what needs to happen here is some coordination needs to be established across the signers in the multi-signer group. In the draft, we mention a few possibilities. Probably the simplest one in our view is to essentially partition the key tag space and allocate subsets of those partitions to the various multi-signer parties. And then each party just keeps potentially repeatedly generating a new DNS key until its computed key tag falls within its allocated partition, right? Otherwise, just repeat until it does. The second idea is to have a central key broker service. So that requires deploying another piece of infrastructure, of course, in your DNS system, and have all the parties communicate with that, and that central entity enforces uniqueness. You can also have the parties communicate with each other directly, and you need to avoid race conditions so that not more than one party is trying to generate a new key at the same time, which would make it very difficult to detect collisions. And of course, there's probably other possibilities you guys will come up with. You can go bananas and say, okay, we're going to have everyone implement a distributed consensus algorithm. We're going to elect a leader. That leader is going to do all the collision enforcement, all that stuff. I suspect people are going to be pushing. Those will work. I suspect people will push back on those ideas and try to select the simplest workable idea, which may be the first one. Next slide, please. So here's some more details about the partitioning key space idea. And looking at the slide, I feel like I may have said all of this already. So maybe there's no need to rehash it. Oh, there is one subtle point I wanted to mention, that what you have to do is you have to generate the, calculate the key tag, not only for the candidate key and its current parameters, but also with the revoked form, right? Because you may revoke the key at a later date, and that will change the key tag computation. Next slide, please. And yeah, that's all we had. I don't know if it is too premature to ask this question already, so I'll look to my chairs for guidance, but at the very least, I'm hoping we can have a little bit of discussion and Q&A. So I'm here, and my voice hasn't given out yet, and I haven't coughed, amazingly enough. Jorgis is over there, and Mark Andrews, I hope you're online and able to participate. And I think I do see him.
Yeah, I'm here.
Jim Reed. Siobhan, I think this is a well-intentioned but probably bad idea. I'm sorry. I would be happier, more comfortable with some language that says in an updated document, you should avoid key collisions, but rather than have you must avoid key collisions. There may well be circumstances where it would be perfectly valid to have two key tags that end up with the same value, albeit if they're for different keys. I can't imagine that scenario, but it may be a potentially valid circumstance that could arise, and I don't think we should be legislating to prevent that from happening in the future. I'm also concerned about some of the suggestions you're talking about here, is we're adding really more moving parts to an already complex ecosystem around DNSSEC and DNSSEC signing and validation. I'm not sure that's a valid thing to do, a sensible thing to be doing. It's not going to help with the uptake of DNSSEC, in my opinion. And so I don't think this is the way to go, particularly as we now seem to be moving towards a state where we're potentially having multi-signers or different actors involved in signing the zones and all the rest of it. So I think creating this complexity may create more problems than it actually solves. So maybe some language that just says, avoid key collisions, but don't make it a mandatory requirement, or come up with a new protocol and protocol engineering to get around that particular issue.
Okay. Mark, do you have any comments? I'll let you go first.
Well, Byte's already been doing this for 20 years now, avoiding key collisions. We have code which will actually do key ranges. That's actually in what's shipping at the moment. You can specify key ranges, and the key generation will look at that. I don't see the theoretical problem Jim is saying is going to happen. It hasn't happened in 20 years.
Yeah, well,
this isn't hard.
Mark,
this is not hard to do. It is trivial to do.
Okay, well, in that case, okay, I agree with you, it might be hard to do, but then let's have some evidence-back work to underpin this effort. How often have key tags actually happened in the wild? How often have they created actual problems? You know, are we trying to solve a problem that needs fixing? It's not clear to me that's the case. And I think adding more moving parts to an already complicated system is not sound engineering, in my view.
Yeah, so Jim, so we know key tag collisions happen in the field. They're relatively rare, except for the case of attackers deploying specially crafted zones, right? So they do happen, and they don't cause an operational problem because validators know how to deal with it, right? They just have to do extra work, extra unnecessary work. And that's one of the things we're trying to get rid of, trying to make the validation process more efficient. On your point about additional complexity and more moving parts, I totally agree, right? So, but guess what? Multi-signer has already introduced additional complexity.
I'd like to see that go too, but that's another story.
So, okay.
I know.
In fact,
for
this
time
might make...
management, I like to keep answers and so the questions and answers short, because we have 5 people in queue.
All right, yeah, let's go to the next one.
Yeah.
Christian Almot, Cloudflare. In the interest of making this a smooth update, can we avoid the aliases stuff and all of that, and rather just, in the essence of interest, either set a flag date or pick one of the other options?
Yeah.
And as I have particular interest in multi-signer, the easiest option is usually the one where you don't have to deploy a coordinator software for the key updates. So either the ranges or just, let's just agree not to collide.
Yep. Sounds good. Yeah, I'm okay with whatever we come to a consensus on that.
But this is an important draft to get adopted, in my view, because it's causing issues. because of the key trap, we've seen zones taking advantage of this.
Right. Okay, thank you, Christian.
Peter?
We can't hear you, Peter.
We can't hear you. Okay, Roy, and maybe Peter will come back. Roy, can you go?
Yeah, Roy Adams, I can. I think this is an important draft for the sole purpose of protecting validators of being abused. Anything else is really not that important. Sure, tools can be written in order to avoid key tag collisions in the signal zone, etc., etc. The sole purpose of this, and this is why I think it's important, is that validators are protected against denial of service attacks. What also not many people know is that the key ID is not limited to 32 bits, or sorry, to 16 bits, but even less due to the algorithm used to calculate the key tag. So collisions are a little bit more on accident. How do you call that? More, they in theory happen more often than you think,
Yeah.
but it doesn't matter if they happen by accident. It's the miscreants that create these attacks that can make use of the idea of having multiple algorithms, sorry, multiple keys having the same key tag.
Yep.
That needs to be protected, and that's why this is important. Thank you.
Okay.
Agreed, 100%.
Ralph, final question. Oh, Peter?
Next try. Can you hear me?
We can.
This excellent. Well, I want to say that we need some sort of document like this because the validators are actually enforcing that with possibly not the limit of one, but maybe two keys, or like, every implementation has a little bit different limits, but they are in place and people are not aware. So I think that not documenting that clearly and preferably agreeing on one value is a mistake, because it is then causing operational issues in practice with resolvers because of the anti-key trap mitigations, right? So it's not the question whether we should do it, because we are already doing it and we need to do that. The question is whether we document it as a working group document or not.
Yeah, I think I agree. So I think there's some confusion because different limits are being applied by different implementations, right? And things can unpredictably fail now. So it's cleaner if we just decide there's no collisions and that everyone is forced into the same behavior.
Ralph, final question.
No, it's not a question, more remark. So I'm also supporting this work. And again, having a kind of a hard stop, we don't do collision is much better than what we currently have. And I did research the number of existing zones when we had key trap, but I just looked at my laptop, couldn't find it, but it was very, very low. So I think the overall problem space also in the real life is very low. And we have kind of technologies to kind of avoid it in the future.
Okay, yeah. Thanks, Ralph.
Thank you. Yeah, there's interest in the working group, but we also have to manage the load of the working group. So we will also discuss with the AD how to go forward. Thank you. Johan.
So my name is Johan Stenstam, and I work for the Swedish Registry. And our general interest right now or rather our IETF activity interest right now is finding solution to automation problems that cross organizational boundaries. And incidentally, what Truman just talked about is, well, possibly an example of that. So we started out with Multisigner, and just to be clear, I have a fair number of slides here. So in the interest of brevity, I will probably skip a number of slides to get to the heart of the matter. We started with Multisigner, which is sort of an interesting problem space. And we realized that we can actually address a much larger problem space by sort of widening the scope a bit, and that's where we are right now. So this is about how to signal what the zone owner wants to happen in a case when he has more than one DNS provider. So let's look at some details, and I will be quick here, and you can look at it afterwards if you feel like it. This is obviously not difficult. You have a zone owner, you have a bunch of name servers. Easy. You have a provider, and that provider does Anycast, for instance. That's easy. What about DNSSEC? Still easy. What about multiple providers? Well, this is where it starts getting interesting. Suddenly you need to synchronize the NSR set somehow. Obviously, each provider could tell the zone owner, and the zone owner does the management of the NSR set, which is sort of a classical style way of doing this. But someone needs to do it. And typically, zone owner gets less and less clueful over time for reasons I don't quite understand, but it seems to be a fact. And that means that instructions from the DNS providers about what they should do in their zone is a potential problem. What about the DNS case? Well, let's assume that we have one provider that signs the zone and another provider which doesn't sign the zone but serves the zone, and suddenly you need to set up zone transfers between these two providers. How do they find each other? How do they sort this out? Well, typically they get some sort of instructions from the zone owner, and then they find each other somehow through, what do I know, phone, email, something, and they sort it out. But there is manual steps in the process, and because there are manual steps in the process, even when they sort it out, which they do, typically 3 years later when something needs to change, the guy on the other end is no longer there. What about a really interesting case then, when you have multiple providers that actually sign the zone? This is the multi-signer case. This is where we started. Well, that's when it starts getting dicey, because no longer do you need to synchronize only the NSR set. You also need to synchronize DNS keys, because my KS keys need to sign your zone signing keys and vice versa, etc. And dealing with key rollovers and parent interaction, etc. Well, it's getting dicey. So that's why we don't really have multi-signer as a standard thing today, because it's too complicated and we haven't fully automated it. Can we possibly find a solution to this? Well, I think we can. And this is me skipping a bit. One of the things we have to realize is that when we have multiple signers that in various ways contribute to the contents of the zone, they contribute through adding NS records, for instance, or they contribute because they are adding DNS keys, or they possibly contribute because they need to negotiate and decide that we need to publish a CDS or a C-sync record. Suddenly we have more sources of truth, because we have stuff that comes from the zone owner, so he is the source of truth. We have stuff that comes from the signer adding DNSX stuff, and then we have this synchronization stuff that sort of comes from the side. But we want the synchronization stuff to arrive upstream of the signer, because a typical signer is either a secondary and signs the zone, and then it doesn't accept things like dynamic updates, etc., or it's a primary and then we get other problems. So we want to have the synchronized stuff arrive upstream of the signer, but at the same time, because of the clue level at the zone owners, we want to synchronize stuff to arrive downstream of the zone owner. And that gives us a new component, which I call the combiner, for lack of a better term. So the combiner is something that sort of just synchronizes the massive amount of zone data that comes from the zone owner, and very small but still important stuff that comes through these synchronization efforts. Sends it down to the signer, which signs it, serves it, and etc. And then we come to the heart of the matter. How do these providers actually do the synchronization? And that's the thing you see in the middle there. So I talked about this, and now we get to the interesting parts. So this is what we suggest to address this problem. We suggest that we have a new record set called tentatively HSync. The HSync RR set for horizontal synchronization. This is something where the zone owner states intent. This is what I want to happen. This provider is the provider that I want to sign my zone, or these multiple providers in the multi-signer case. And this provider should just serve the zone. And this provider should possibly get the zone from that provider. And who should manage the NSRR set? We specify all of these things in the HSync RR set. So it becomes clear to everyone, to all the providers at the same time. They all see the same information. There is no possibility for the confused zone owner to give one instruction to one provider and another instruction to the other provider. It's just clear to everyone. And should there be a mistake, everyone will see the mistake and they can sort it out. So let's do some examples. Let's start with the most complicated case. This is multi-signer. We send the zone, the unsigned zone, to two providers, both of which sign the zone. So there will be synchronization stuff, the things that I call agents. They could be integrated in the signer, doesn't matter, but I call them agents. They talk to each other. They sort out the synchronization stuff. They send that over to this, let's call it glorified proxy, which sits between the zone owner and the signer, which we call the combiner. And we sign the stuff and we're done. We describe this in the HSync RR set. And you have two examples here. In the topmost example, it says that the owner manages the NSRR set. And it says that both providers sign. And then you see the interesting part, which is the identity of each provider. And because you have the identity of each provider in the HSync RR set, they can locate each other. When they get a zone transfer, they look in the HSync RR set and see, am I a part of this? If not, I don't care. If I am a part of it, let's look who the other parties are and locate them and start talking to them. Yes, it's complicated. Lots of boxes. Let's focus on the important stuff. The important stuff is to look at this from the point of view of the zone owner. The zone owner doesn't really care about the internal infrastructure inside, let's say, NS1 or Cloudflare or one of the other major providers. To the zone owner, this is just about where do I send my zone transfer, assuming I do send a zone transfer. It's not a managed service. It could be that I'm just using a web API, but that's a different thing. And where does the zone get published? And in the end, how do the multiple providers actually talk to each other? So that's really the key of the matter here. How do we make this communication happen? And as I said, we realized quite quickly that there are more cases here than just multi-signer. So this is a case which is hard to see here because I made the boxes black. The leftmost provider actually signs the zone, and then you see there is a zone transfer going out over to the second provider, which only serves the zone. Again, the only thing that the zone owner cares about are the things that you see outside of the black boxes. And the HSync RR set examples describe this. So if we look at the lower case here, the lower example, it says that agent signer dot provider A signs the zone. That's why there is a sign in red. And the other provider, provider B, doesn't sign. That's because it says no sign. But it also says that he gets the zone from the upstream, which is the rightmost thing. And that says, essentially, I, as the zone owner, want provider B to arrange zone transfer from provider A. And that's yet another thing they need to talk about over this connection and sort that out. There are more examples. This is a case where the zone is signed by the owner and he has multiple providers. It's sort of the same thing, except we sort of integrate the zone owner into one of the boxes. Here is a case with an unsigned zone. I mean, this is really not about DNSSEC. This is about multi-provider communication. And that brings us to the rather important question of exactly how do these guys communicate with each other? And how do they find each other? And is the HSync RSet an aid to a potential attacker, etc.? Well, obviously, you need to get the zone in some sort of sufficiently secure manner. But that's a problem we already have. So if you haven't solved that problem, you're already in a world of pain or potential pain. And you can do that with TSIG or VPNs or zone transfer over TLS or what have you. That's a problem you still need to solve. What about communication? Well, we are trying to play with both API-based communication and DNS-based communication. They sort of work the same from our point of view. We start by looking up a URI for the identity of the provider as published in the HSync RSet. When we have the identity, we look at the target of the URI. We look up the SVCB and the 60 key for the DNS case, or we look up the SVCB and the TLSA for the API case, and then we start talking. So we do the TLS-based authentication. We do the verification against the TLSA for the other guy that we have verified through DNSSEC. DNSSEC is absolutely a requirement for providers, while it's not a requirement for the zone owners. So this started in the multi-signer context, obviously, but now we think that there may be actually be a larger applicability for the non-multi-signer cases. We have most of this working, actually. We have a prototype combiner that does what it should do. We have an enhanced TDNS agent, which is the same thing that we're using for the delegation synchronization stuff that I will speak about in 2 minutes. And we've enhanced that to do the HSync analysis, look up the information for the other providers, establish communication, start talking to them, and we are starting to send messages back and forth where they synchronize stuff. Obviously, we haven't described that protocol yet, and that will be the topic of an upcoming draft. Just to wrap this up, there's an older draft of ours called Delegation Management through DNS or through DDNS, which is essentially this thing, if I sort of put that into the context of the previous part of the presentation. So the delegation synchronization, that's the red stuff. And the red box up to the left is the parent, or rather the parent receiver as published through the desync record, which seems about to become an RFC. So the delegation synchronization stuff fits into this larger problem space, but it's separate from the HSync stuff. So the desync is the sort of vertical synchronization infrastructure, and the HSync is the horizontal synchronization infrastructure, but they do fit together. We've solved a couple of problems that we realized ourselves, and we got some feedback from others, and we've addressed that, and we made the model slightly more robust and slightly more sort of, it will recover better in case of certain corner cases, like people losing their keys and talking to the parent and asking whether they trust a particular key, etc. Because of this added support for recovery, we needed to make the communication slightly more complicated. And because the communication is slightly more complicated, we needed to add, which brings me to the last draft, a new eDNS0 option, which we call key state. So key state is essentially infrastructure for the delegation synchronization draft for the child and the parent to be able to express sufficient details about what keys are known and trusted, what keys are not known and trusted, and why are they potentially not trusted, and let's bootstrap again, etc. So the key state draft is needed for the delegation synchronization stuff to work, and the delegation synchronization stuff is sort of a add-on to the HSync stuff. And that's it. Sorry for the speed.
Thank you. Any questions? Okay. No questions. No. And well, there has to also be an interim on this topic with more details. You can watch the Meet Echo session back if you go to the data tracker. That's it. No other questions. We'll continue discussing because it's a set of drafts. There has been some discussion on should they be kind of managed as a single set of drafts or individually. Maybe you can comment on they fit together, but you prefer to have them managed together or as individual drafts through the working group? It's an open question, so we make no decisions, but it's maybe good to test with the working group.
I don't have a strong feeling about that. We can do one at a time. Well, not necessarily one, but possibly two, because key state and delegation synchronization really must be together. I think it would be unfortunate not to deal with all of them, but not necessarily at the same time.
Okay. Yeah. Okay. Thank you.
Thank you.
Okay. Thanks. One moment. Next is Paul Hoffman, remote, in the hotel, but
sort of remote, yes. By the way, do people prefer to see my giant ass head, or should I just go to audio only?
head, I hear, in the room.
Head. I've got a head. You can see, you can
yeah.
almost figure out which room I'm in.
You want to control over the slides?
No, please just go
Okay.
ahead and do it. This is going to be very brief because we've already started discussing this on the list. And also, it's not that important of a draft. So if the group wants to dive in to, for example, Johan's draft, I'm surprised that there was no Mike line, because I thought his drafts were excellent. I thought that the idea of doing this all in one place was good. But anyways, we can do this whenever. So next slide, please. So you can tell that I'm not a comedian. This is the one joke that I have during the presentation. But basically, this is a draft about how to use copy and paste better. Next slide. I want to emphasize that DUJ has a super simple use case, which is that people currently tell users, just, paste this into your web host. And for people who have a good web host or who have a web host that allow you to do that, that often works, doesn't always. But also you have to tell them, please paste this in, and often users have no idea. And so they often say something like, use your DNS provider's web interface. And many users have never seen that before. So here's if you have seen, and again, this doesn't really apply to almost any of us in the room, but if you have seen these places where you can paste things in, they're not the clearest. Next slide. So the simple solution is a text format called DUJ, which is DNS update with JSON. You will all thank me for not doing this with YAML. So instead of saying here is the service provider, instead of saying here is a record to paste in, they say here is a small glob of text, which is JSON. Please paste that in. And so really the expectation is the user would copy and paste. They wouldn't retype anything like that. So really, that's all this is supposed to do. Next slide. And truly, this is just for users who copy and paste. Someone else on the list said, "Oh, you can extend this to this and this and this." Let's not. There are much better ways of doing, telling people how to do complicated things than this. It certainly is not meant for any automatic zone updates. It's quite limited on purpose, and there are many other ways to think about this, like, are all service providers trusted by all hosts and such? So if you take a look at Domain Connect, for which there is a mailing list in the IETF called DCON, they in fact have a different model, one that I think is overly complicated, but they seem quite willing to work on it. But it also has many more use cases. And in fact, there is a trust model involved with there. In DUJ, there is no trust model. It is the same untrusted model as your service provider saying, paste this stuff into your web UI. Next slide. So for those of you who've been following on the list, this is what a DUJ looks like. They can be typed in, but it's likely to introduce errors. Fortunately, a JSON parser might find the errors, but regardless, this is not meant as to be typable. And then there is a second type of string called DUJ64 instead of DUJS, which is just base 64. So no one's going to try to type that. I'm not terribly thrilled with DUJ64, but a bunch of people want it. It's like, sure, no problem. Next slide. The motivation here was giving users more specific actions that they didn't have to understand what was going on, but they might. And when I say they might, I don't mean like us in the room. I mean other users who see some JSON code and they see something that says add, or they see something that says delete. They might get a feeling for what's in this blob of text. And so that leads to another major advantage of DUJs. Right now, there's no real way for an application provider to say, remove this record. Because at best, many of the DNS hosters allow you to add records, but they don't want you deleting records. And yet we know that many times we want people to delete records. So this has that just fine. Next slide. It's operational, so DNSOP seems fine. The initial response in the mailing list seemed positive, modulo some changes. Some of you will have noticed that I responded to a message from over a month ago this morning. Sorry, Peter, I had totally spaced it out. But like I say, I believe much of this will be bike shedding, which is fine. Bike shedding works well with JSON. And it does tie into another document that the working group is looking at, which is DNSOP domain verification techniques, because that document specifies creating an underscore label for all of this type of data. Instead of a host saying to you, first go and add a subzone to yours. Now that you've added a subzone, add this record. They can still give you a single DUJ string. And that might be super helpful. And next slide, which I think is questions.
We are on the last slide.
Oh, okay. I didn't even do a question slide. So thank you.
Questions? Tobias.
Tobias Max Planck Institute for Informatics. I would personally caution against DOJ, and if at all, recommend DOJ 64 for the very simple reason that I would be careful about putting double quotes into any copy-paste buffer of a modern device, because they will be bit longer than ASCII. And I think that would be like a great source of user confusion.
Yep. Thanks.
Peter?
Hi, it's Peter. So as for the format, the number of actions that are described by a DOJ, whatever message or string, or like it's a list and then it contains other lists, and each element of this inner list is an action, and the first element of that is, for example, add, and the second element is the record that's supposed to be added. And if I want to add another one, I add another list or sublist, which again says add, and then this other record. So I have to repeat all those add statements, and if I want to delete several, I have to repeat the delete statements. And I was wondering if it wouldn't be better to only have one sublist for all adds and one sublist for all deletions. So I would have one sublist at the first element of which is add, and then there may be one or more record strings after that within this add sublist to list them all essentially. The same for delete.
Yep.
So that's the first question, if it would be better. And the second question is, what happens if one such DOJ string describes adding and removing the same record? Is that just ignored?
So
or is it
these are the
invalid, or
questions
in order?
that I answered on the list this morning.
Oh, I'm sorry, I didn't see that. I'll take it all back.
Well, and don't take it all back, because both my answers were, well, sure, maybe. You know, it wasn't definitive, should or should not. And again, I apologize for taking over a month to respond. Thank you for nudging me.
Thank you. Pavel?
Paweł Kowalik, Domain Connect enthusiast. So I like DOJ from the perspective of its simplicity and the use case. What I don't like in DOJ is it makes has this assumption of application provider always looking up the zone before generating a valid DOJ for the zone. So basically, for the very simple use case that the DNS configuration would be static one, the DNS provider, the provider cannot just have a static DOJ, and I think there's a large limitation to this.
Can you say more? I'm not sure why you wouldn't want them to look up.
Because sometimes they would want to just hard code it.
Okay.
Without looking at the zone, and then without interacting with DNS, it's difficult.
Okay. I don't think that it's required, but if it is, then I can work on that.
Thank you all. We closed the queue, so sorry, Ali. We don't have time. We go to the next presentation. Thank you, Paul. We continue discussion, and yeah, also for adoption, that's a separate, we will discuss it also with the AD. Next one is Donald with 6.0. Donald? Okay, I thought it was in the room, sorry, apologies.
Hi there, no, I'm remote. So assume you can hear me.
Yes.
Okay.
Donald, do you want to, I run the slides, or do you want to have control?
Either way is fine, I don't know. You want to give me control, I'll try that.
Okay, you can run them.
Okay, so I'm Donald Eastlake, currently unaffiliated, and this is about DNS 6.0. So this is not about TSIG, but TSIG is an updated way to do transaction signatures, a pretty recent RFC. It's a meta RR, and it enables you to do authentication integrity for requests and for transactions in the DNS, where a transaction is considered to be the concatenation of a request and the resulting response. But it assumes you have a shared secret key, so it can use a keyed hash algorithm. When you don't have any shared secret in place, then 6.0 provides a way of doing the same sort of things, but by using a public-private key pair. So it uses the SIG-RR, which is the earlier name with a different RR code for the RR sig. So it has exactly the same structure as the RR sig, but has a type covered field of 0. So it's used to convey a signature produced by a private key where the authenticator has access to the public key that they can use to validate that signature. So you can use it to authenticate requests and responses if you have host-based keys that are sort of provide better provide integrity and authentication, that the message hasn't been tampered with, and that a response is the only response to the request that you sent, and so forth, by using keys that are associated with hosts, servers, whatever. You could use it to authorize updates and the like if you're using a public key that's associated with the zone, and you could authorize other kinds of things if you have using keys associated with other types of authority. You can also use it for securing a T key, which I'm not talking about in this presentation. So these keys are normally stored in the DNS with a key RR, but you could get them from other places. And so there's some problems with the SIG0 currently. There's no error field. Both TSIG and TKey have one, which is good. It has no original ID field. So if you need to know what the original ID was if you're trying to validate the signature, which is not a problem if it's just one hop. But in cases where it might be forwarded, then you do not have obvious support for that. So Bind actually does support this by using TCP, always using TCP when there's a SIG0, and by basically using the same ID, maintaining a separate ID space per TCP connection. But that seems like a somewhat onerous requirement to impose on everybody. So the current RFC 2931 BIS, so it's the update for SIG0, removes a statement that TCP support is optional. It has some changes to make it easier to check the validity. There were cases like where class was allowed to have 2 different values, and the revision just says it has to have the value all, hex FF. There's a section added now at this time about considerations on forwarding servers. And the current 2931 BIS draft adds a EDNS0 option that can be used to carry the original ID and return an error value. So there's some questions as to which way this draft should go. One is how should you handle this original ID and error return value? In the current draft, there's this EDNS0, sort of option A here. Option B would be to reuse TTL. It's got enough space in it for both of those. Might be a slight increase in the chance of erroneously caching the RR, but it's an old RR and people should really understand it. Also, you could specify a new RR that would handle these fields, but then you'd have to be able to, parse and create this new structure. There's another presentation on key state, and that also proposed an EDNS0. So I'm just saying, if you have the more new things you have to convey, the more it seems to me it might be better to go with option C, because that would give you the most general way to do this sort of thing. The other question is whether you should allow more than one SIG0. Currently, the standard and the new draft say you can only have one, but it'd be pretty easy to specify how to do that. Each one would just sign the material before it. There wouldn't be any case where the SIG0 signed another SIG0 or anything like that. There's cases of forwarding where this would be useful. For example, you have something authenticating some update, but it has to be forwarded through a forwarder, and the forwarder wants to use a SIG0 to get better integrity control between the forwarder and the ultimate server that's going to process this, and so forth. There would be no intent to change anything about TSIG. So you'd either have nothing, you'd have one TSIG, or one or more SIG0s. You would never have both TSIG and SIG0. The simplest possible extension with no changes to TSIG. So I have a little chart here. You have a single SIG0 or multiple SIG0s allowed, these various ways of handling it. I view the case where if you allow multiple SIG0s, but you're trying to use the EDNS0, then you have to have some way to connect the two of them. And there is a proposal for how to do that in the key state, but it just seems a little complicated and fragile to me. So I guess that if you were just adding the original ID and the error code I would tend to lean personally towards TTL. But if you're going to add enough new stuff, then maybe a new RR would be better. But it can be done with the EDNS0 option. So my plan was to update the draft based on what the people's feeling is on those questions and working group feedback. And after it was updated, then call for working group adoption. But there may be more complex things if there's some desire to combine this with the key state draft. So that's it for my presentation.
Thank you, Donald. There are 2 people in the queue. Ted?
Ted Lemon. First of all, I don't know if you know, we're using SIG0 heavily in the SRP document, which is hopefully going to become an RFC pretty soon. And we've actually been wrestling with the question of how we deal with forwarding, and I have been thinking about doing some way of wrapping an additional signature. So it's a nice coincidence that you're also thinking about this, and certainly this would be something that would be a useful feature for us. As far as the RR type, the new RR type goes, I think that's the right way to return the data, but that's just sort of a off-the-cuff reaction. I don't know that I'm right. But anyway, yeah, definitely could use the new, the ability to multiply sign, and I would like it if some working group would work on this. So it'd be great if it was.
Okay. Okay, I would just say that the text on special considerations for forwarding in the draft is simply pretty much cloned from TSIG, but just tweaked to say SIG. And
Okay, thank you. Next is Peter, remote.
Hello. One thing is not clear from the current BIS text, and that is how compatible it is with the existing 6.0 deployment, because we have installed base with 6.0, and I can tell from the text whether these are like little tweaks which will just work with the old clients or servers, I mean, on either side, or whether there is some lingering incompatibility somewhere, assuming you don't use the new features like forwarding and stuff.
so you're asking how compatible it is with existing implementations? Yeah, I
Yes,
guess
that's
I'm
my
not sure, and but I'm happy to change, make any changes that are necessary to improve that. But I haven't investigated it myself.
With my implementer hat on, I would say that if we are going to keep the RR type as 6.0, we should really explicitly demand in the spec that it has to be compatible with what we have now. Otherwise, we need to use different type.
Okay.
Because any other way, we will end up with like either old client or old server talking to new client or new server, and it will just explode and it will be hard to debug. So yeah.
Hopefully it won't be too big an explosion, but yes, I agree with you that what do you say about RR types?
Yeah, other than that, if there is a demand from DNSSD, it makes sense.
Okay. Thank you. Thank you all, and we continue to work in this working group, and there's interest from the other working group for sure. Thank you.
Next up, Yorgos and Jira and DNSSEC.
Hi there, I'm Yorgos and I will talk about Dry Run DNSSEC today. Yes, so for people that they're not familiar, it was inspired by DNSR reporting, and which is now in RFC, and DMARC, which has a feature to soft fail and report any errors back to the operator. Disclaimer, I'm not going to describe version 3, the current version of the draft, because while preparing for the IETF, we discussed with the authors and we said we can make it simpler. So we removed some stuff, but I will come back to it later. So the use case, you have an insecure zone, you want to sign it, that's fine. You go and sign it, you publish it, but you don't publish the real DS record in the parent. Instead, you publish a dry run DS record, and that means It's a DS record that has a specific dry run algorithm. So resolvers that they don't know about it, they keep treating the zone as insecure, and resolvers that they do know about it, they will try to validate. If a failure happens, they will report error back with the, DNS error reporting, then fail back to insecure. If validation succeeds, they can already set the AD bit, so you can get some opportunistic security, which is interesting if you want to start testing applications that require DNSSEC, like DANE, for example. And when everything's okay, the operator has a turnkey action. They just need to update the DS record. They don't need to resign anything because it's proven to be working. But the question now is, how do they know that everything is okay? Because only errors are reported. For that, we need a no error report. We need to translate the absence of failure reports to positive messages. So a resolver that tries to validate a dry run zone and it doesn't encounter a validation error, they can just say, send a no error report back. This has to be per zone, not per every single record in the zone. And that gives a signal to the operator that say, okay, a dry run resolver is out there. It tried to resolve my zone. Everything was okay. I have a confident signal back that at least someone is looking at my dry run DNSSEC part of the zone. I want to talk a little bit about signaling and provisioning. So signaling, as I already mentioned, happens with the DS digest type algorithm in the DS record. The intention in the draft is to burn a bit of the whole space so that every algorithm has a dry run counterpart for it. Currently, we only describe a counterpart for SAT2, but this will probably change in the future. And provisioning happens with the DS record itself. The parent needs to know about dry run, and they can either accept the DS record for the child, but if they don't and they generate their own DNS key, somehow they need to get that intention from the child. Either they can pick up the DS, have a UI option, or some other means. The same works for CDS and CDNS key. And in this case, it seems that burning a specific bit, like the leftmost, for example, will make things easier because that bit itself is not part of the algorithm. It needs to convey intention that dry run is in use, so it's easier to parse and work in the code base. Yes. So if we have everything in place, we can go an extra step further and we can say maybe a client needs to get the dry run security status back from the resolver. So we can have a new DNS0 option and they say, okay, give me what was the status of the dry run zone. And then the resolver already knows because it has already validated. And they can either reply with a normal answer if everything's okay, or turn the bogus record back to a SIR fail. Then we can have easier debugging from the client side. And if an application, we know that an application talks to a resolver, then we can see how that application reacts if the DNSSEC of the zone breaks. So now I'm coming back to what I mentioned at the start of the presentation, that we left some stuff behind. Although dry run DNSSEC can theoretically work on already signed zones, that can become complicated because you give the intention of dry run DNSSEC through the DS record, and that's fine. But the DNS key set is only one, and then the resolver needs to figure out which of those keys are supposed to be dry run and which are not, which is not trivial to do, and it doesn't always work. So we left it out. But whatever happens with the delegate working group, we'll have the ability to point to different DNS key sets altogether, and then we can mark different DNS key sets as dry run key sets, and then the whole logic can work, but that's something for the future. And if we re-enable that, then we can test experimental DNSSEC configurations that are running parallel to the real ones, and we can even test whole key rollovers in the dry run part of the zone before even actually starting to do the rollover itself. Of course, there is a security caveat, especially for the insecure case, because now bogus answers turn to insecure, so there's no protection anymore. This is a feature, it's not a bug, but I've put this slide here because we got feedback from TLD operators that they there are some TLD operators that give incentive for zones to be signed, right? But if you do dry run DNSSEC, that's a very welcome first step for your zone to be signed, but it shouldn't be secured DNS signed in this case. We want you to move forward and have a proper DNSSEC in place. So why we do all this? Yes, we need to test in production, the real production, because we already test in virtualized productions. We test in production environments that are really close to production, but not the real thing. And we've seen a lot of cases that they blow up. And one beautiful thing that comes out of it is that the turnkey solution is everything works, and then you just go and mess with the DS record itself. You don't need to resign anything. You don't need to do something that it will break your zone accidentally. DNSSEC adoption, will that help? I don't know. As of this month, I think RFC 4035 is 20 years old. So I'm not very hopeful, but at this point of time, it can be a happy coincidence. I don't know. Yes, and I will need to close my presentation now. And I've been living in the Netherlands for quite some time. And I want to close with a very famous Dutch saying, which I think it goes something like, if life gives you lemons, you deploy DNSSEC. It seems to be happening in the Netherlands. That's the end of it. I'm happy to answer any comments, questions, and ask the chairs what are possible next steps for a call for adoption. Yeah.
Thank you, Yorgos. Peter, remote.
Hello, once again. What's the interaction with aggressive caching? Because some of the breakage we have seen in the wild and the headline making breakage like Slack.com was caused by aggressive cachings, not like problem assigning or anything like that. So if it's dry run, is it supposed to trigger the same aggressive cache behavior as if it was like real stuff? Or what's the, these little details?
You mean if the error itself is in the parent zone before even following a delegation?
No. In the case of Slack, if I remember correctly, they signed almost correctly, except for bitmap or something like that. And when they deployed the DS, validators started to actually use the DNSSEC validated aggressive cache, and that's what caused breakage. So I'm asking if I switch on the dry run bit or whatever it is, are resolvers supposed to act as if the zone is signed and thus use the aggressively use the DNSSEC validated cache, or
I don't remember exactly the Slack incident, but was the aggressive part in the parent or the child?
And the child. And the child was signed slightly incorrectly, and that's what caused trouble with the aggressive caching, if I remember correctly.
Yeah,
but even if it wasn't Slack, I mean, the question stands like in generic terms.
I think I will need to think about it because everything was coming back correct. Like there were just some things that were disappearing from the zone, right?
Yes, because of aggressive cache, basically, yes.
Yeah.
Because the type bitmap claimed that something doesn't exist even though it was in the zone, and if the resolver got the answer for the negative with the proof of non-existence first, then it fell over. Maybe Peter Thomason remembers, he's after me in queue, so I will give him a floor if you don't mind.
Yeah. So if validation itself fails, then the validator can just ignore it, report, and then give an insecure answer, right? Or continue the insecure path. But if the aggressive NSEC just proved that there is nothing there where something should have been there, I don't think it would help. But I'm not sure what was the exact
Yeah, that's the case I had in mind, yeah.
So I can think about it and then talk to you offline if you want.
Yeah, sure, we can discuss.
Peter?
So if dry run is turned on, I suppose there is some checks that one would typically run before determining that all is fine, and you then do the turnkey action. I think that's fine, but I think we can also try. So instead of just signing a zone and then seeing if it works and doing dry run. We could also try to impose the same configuration checks on parents that are accepting DS records. So for example, if there is a bad key in the DNS key record set, or if the DNS key set is not signed by the key that is referred to by the DS record, for example, I think we should, instead of, or maybe in addition to dry run, also tell the parent, look, if you're accepting this DS record, do a practical check and see whether it actually works. And if it doesn't, reject it. I think this would prevent much of the screw up. And it of course might not help if there is like a wildcard problem with denial of existence at Route 53 with Slack or something, because you won't see that at the DS record checking time. But I think we should precisely think about what are the checks that should be done at dry run time or at whatever some other times the checks one would make, and then should or must level kind of requirement on the parents to do those checks before changing DS records.
I like it. Yeah, that's a nice idea.
Okay. Thank you. Yeah, we will discuss it with the chairs and also with the AD about the next steps. The proposal has been presented a couple of times, 2-3 times, I think, over the years. So
I think this is a third, yeah.
yeah, so we have to make some decision here how to go forward. Thanks. Next up is Warren with .internal. You want the clicker? Yeah, you want. One moment. Now in control.
There we go. So, hi everyone. Yeah, the clicker does work. So first off, some disclaimers. I've been working on this sort of stuff now for like 8 years, and I'm getting a little frustrated and a little ranty. So if I start frothing at the mouth, I will apologize ahead of time. Also, this is co-authored with Kim Davies and Andrew McConaughey. Clever bits are theirs, the stupid bits are all me. So, some important history. Back in 2017, I wrote draft W. Kumari DNSOP internal, and I brought it here, and I said, dear DNSOP, let's do this. And the feedback that I thought I got from the room was, maybe, but that's definitely not DNSOP work. Go do that in ICANN. So went along, discussed this in ICANN. In September 2020, ICANN published SAC 113, which recommends that the ICANN board reserves a name for private use. There was also some liaisons that went back and forth between ICANN and the IAB, and I can't actually see the timer. 9 minutes, okay, great. And then, as I say, SAC recommended that a name be reserved for sort of private use. In 2023, IANA published their intended procedure for selecting a string. There was a public comment period, bunch of discussion back and forth. And then in 2024, IANA followed the procedure that they were going to follow, or that they said they were going to follow, and they identified internal as being a string that met the criteria. There was yet more public comment, bunch of people went back and forth, bunch of discussion. There was a lot of sort of open collaborate, or sort of open consultation, open process, etc. And so this string was chosen, and the ICANN board reserved .internal and recommended that efforts be undertaken to raise awareness of its reservation, and asked the organization's technical outreach group to sort of raise awareness, do that sort of thing. And now we have draft Davies internal TLD, which notes that for various reasons, some set of people want to make their own namespace which isn't connected to the public internet. I'm sure many of us in the room have done that at some point or other, like as a test. You know, I'll make my own fake root, I'll make my own random name in a closed environment test. Sometimes these escape. Ideally, people would always put their own namespace under like a real registered name, but for various reasons, people don't. So, as I say, the string has already been selected. There was a bunch of discussion within the IANA context. the ICANN board agreed with IANA and ESAC and something and has reserved a string. The question I think for us now is, should the string be put in the special use domain names registry? I believe it should. I think if people are going to make up their own namespace, it's much better that they do it on a name which is reserved for this purpose versus just picking something random like home, corp, mail, app, dev, whatever. Putting it in the registry, I think, raises awareness of this. It makes it so that people sort of know which string they should use. And we have this thing called special use domain names. When people search for like, what name should I use? It's likely they'll find it. People seem to think this registry is important. This registry was created by RFC 6761, and it outlines what it means for a name to be special. Sort of what processing is expected, sort of a sniff test for if a name might be special or not. I'll also note that in that same document, it reserves some names which don't really fall into this is special litmus test. Things like example.com, example.net, they don't require special handling by a resolver or client or anything really. It does also put aside some other ones, which sort of is this handled differently is a bit tenuous, like .test and .invalid. But anyway, we looked at this and I suggested a version which has the answers to the 7 questions from 6761. I think it was Peter's suggestion. I stole my answers largely from the inedder.arpa section, and I replaced inedder.arpa with .internal. And so we have things like caching DNS servers should recognize these names in special and should not by default attempt to do blah, blah, blah. Instead, they should immediately generate positive or negative responses. And then it goes on to say, this is to avoid unnecessary load on the root name servers and other name servers. It's fairly clear that the root doesn't really, or it seems as though the root is unlikely to have any sort of issue with the amount of .internal queries. This is from the ICANN magnitude data. .internal is currently the 2nd name down there. It's currently getting like 89 million queries per day, hitting L. But you know, that's currently. And if you scale this up over all of the root servers, it's potentially, you know, on the order of 1% or so. Somebody should definitely check my math because I just did that on the fly. But you know, it would be nice to have these not going everywhere. Again, just a minor nit. Then the question is this sort of work that should be handled in DNSOP? Again, I think it is. I pushed Andrew and Kim to bring the work here, or sort of to let me bring the work here and for us to do the work here, because this is where the DNS knowledge is. It's also seems that if we did want it in the special use domain names registry, it would be better for it to be done here than through the ISE. Seems like if it were done through the ISE, it might still be possible to get in the registry, but that's getting tenuous again. I think whatever the case, the preference is it would be good to have this document published relatively soon, wherever it happens. And again, I think having it in the registry is a good thing, makes it easier for people to find. Ideally, people would never be creating things in .internal, but if they're going to put it somewhere random, not in, you know, a real TLD, better here than elsewhere. So, might DNSOP be interested in working on this? Should it go in the SUDN registry? And I was expecting a lot more people in the line, so 3 minutes. Rocks.
Ted Lemon, DNSOP should work on this, and it should also go in the locally served domains registry.
Yep.
Tommy Jensen.
Sorry, go ahead.
Tommy Jensen. I would suggest that yes, it should be worked on here. Not a hill I'd die on, but I'd suggest considering a may for allowing libraries to also treat the name specially, because likely we're mostly going to know when the query shouldn't go upstream, and that may add layers of defense to inappropriately forwarded .internal queries.
Stuart Chersha, Apple. I wasn't going to say anything, but you asked a direct question for feedback. I'm obviously biased. For those who don't know, I'm the author of RC 6761, so my opinion is probably not surprising. I agree with your logic. It should be listed in the registry, and that way other people doing crazy things that maybe wish they wouldn't, at least they're likely to find it, whereas they may not read every RC that's published. So I think this is harm reduction, and I support your logic and I support doing it.
Excellent. Thank you very much, because a lot of people had pointed at 6761's sort of litmus test for is this special to say it's not. Or thank you. Clarification helpful. Jim.
Jim Reid, I agree that this should be stuck in a registry somewhere, somehow, and there's probably an IETF process issue that needs to be taken care of to fix the issue of how that entry gets made. I don't think it's necessary for the DNSOP working group to discuss this in any great detail. We've got situations now where ICANN, in its infinite wisdom, has decreed that this string has got some special properties. It's not for us to debate that. Our job here, if there is one, is just to say, this is what ICANN said, stick this string in the registry and be done with it. I don't think we need to work on it or do anything more than that. And I think the question here is really one of a process issue. How can something that comes from ICANN or any other external entity be then entered into the appropriate registry? And that, I think, does need any working group input, in my opinion.
It's unclear if there is any process where we could do that from ICANN. I mean, ISG approval, maybe they could be like, I think that the draft specifically is to try and explain to people how they might want to use it, not specifically like this has been selected, and awareness in general. But yeah, I do hear what you're saying.
I'd also say, Warren, to you and to Kim and to Andrew, thanks very much for bearing with through all the ICANN machinations to get to this particular point. It was a thankless job, but I would say thank you for it.
Thank you.
The locally served registry requires that the names have insecure delegations in the public DNS. Tend.ini.ARPA works because there is such a delegation. That allows bring your own devices to work without special configuration. They do a query, they validate, they find the DS record. Well, they find the non-existence of DS proof, and that allows all the PTR records and things like that to validate as insecure. We're kind of, this was .home would have been the right thing to do. We could have had this battle with .home, but you've got this battle now, so good luck.
Thank you. I mean, I agree it's a battle. I agree it's something that should be solved, but I think we should find the generic solution for this for, home.arpa and all the other places it shows up. Maybe that's a best on this. But Paul, sir.
Home.arpa already has an insecure delegation.
Oh yeah. There was another one, I can't remember which, but there was one other that we also had this for in the route somewhere. What was it? Anyway.
.onion, and yeah.
Yes. Yeah, onion. You're right, that one. Thank you.
Paul Hoffman, rarely would I say this, but I'm speaking for ICANN here, to Jim Reid. ICANN did not specify any of the things that are in this draft. So Jim, when you said we should do what ICANN told us, all ICANN told us is, us being the IETF, or didn't even say to the IETF, the ICANN board said, let's get this publicized. And there were choices to do that. We can do whatever we want. I am happy with the current one. I initially didn't want a 6761 registration because I didn't think that it fit in, and I lost. No big deal. I think that the current wording in that registration is just fine.
Thank you. And yeah, thank you for expressing that clearer than I could have.
I have a question, very briefly. How much work do you think the draft needs?
I think somebody to click adopt and then somebody to click publish. No, I think there is some feedback on the questions. I think the questions are basically done, but somebody suggested May for things. I think almost no work because it doesn't say very much. It's like, hey, everyone, you could use this thing if you want. And, here's some stuff I stole from another document. So I think it's done. good artist steal, great art, what, good artist copy, great artist steal, or something like that?
Something like that. Okay, thanks, Warren. And we are at time for this afternoon's meeting, so I guess, let's see. Any of these drafts that we've talked about today that you're interested in, go find them, read them, comment, review. They are all linked from the materials page you can access from the agenda page, so they're easy to find, even if you've never heard of them before. Just go ahead and review those, and the chairs will consult about what we've heard today as far as calls for adoption and so on. And thanks everybody for your time. And wow, yeah, Madrid. Or till next time. Thanks, everybody.